Authentication means some security measures are there. Then the resources, sharing of a single resource are, and a collective means coordinating that resource. Collectively, we are coordinating all the resources. Okay. Now, we are able to see the application layer, the collective layer, the resource layer, the connectivity layer, and the fabric layer. In here, the fabric is the extreme lower layer. Okay. And in the connectivity layer, just we told we have communication and the authentication. Communication means we should have the proper connection, and authentication means the security measure which should be performed so that the authorized user will be allowed to access. Then resource. Here a single resource we are using R, and also collectively they are connecting through the multiple resources to get the applications. Here it is a composite architecture is given. Okay, with the connection of all type of resources and the components, how they are connecting with each other. Now, after the Globus or the grid Globus, we'll go for the peer-to-peer. Now, here, what are the decentralized sharing discovery? Napster and Gnutella. Napster and Gnutella are the example of the peer-to-peer architecture. Okay, and in the also we have Skype and BitTorrent. The previously we have discussed the peer-to-peer network, BitTorrent. Some assignment also have been given. In the last year also some presentation assignment is given for the Skype, how it is peer-to-peer. And
for everything, for Napster, for Gnutella, Skype, everything last year we had.
Yes,
BitTorrent, I think Andrila had given, I think. BitTorrent,
yes,
right?
yes, sir. BitTorrent is given, and after that, Globus grid computing also given, but due to time constraint, I could not able to complete.
BitTorrent was who had presented Globus? Anybody? Had anybody presented Globus?
No,
Is
sir.
it like that? Eh?
No, sir. Globus was assigned to me, but I did not present that, sir.
Anyway, you just check it, how extra you can add it. We'll call sometimes. Okay, we'll assign this Napster, Gnutella, and Skype. One question I am asking you, check it, and tomorrow I'll ask who have checked it. Skype has the least what is that latency time.
Yes,
Skype
exactly.
has the least latency time. So you check it, compare it, and present it. Anybody I'll call, you have to tell, you have to justify it and why. Skype has the least latency time. What is the latency time? Rishabh, Sonni, what do you mean by latency time?
Sir, the time between the sender and the receiver, the time that has been taken by a request from a sender to the receiver, the time in between that has been passed is the latency.
Okay. You just go through, we'll tell you something. You just go through, as I told, it has got the least minimum latency time because of its proper design of architecture. Okay, you go through it, we'll talk sometimes later on. Okay, all these things are very interesting.
Very interesting, sir. Right.
Very interesting. Napster, Gnutella, BitTorrent, Skype. Then we give, I think, Google again we compare. Then we also compare with other Yahoo, and we compare with WhatsApp. All these things depends on your architecture. Why Skype has got the least latency time? Because of its proper design of the architecture. So you have to understand it. Why? You are computer science students, everything depends on software architecture. Okay, Deva, go ahead. Next slide.
Now we'll go for the peer-to-peer.
Next slide. Next.
Peer-to-peer style.
Yeah, peer-to-peer style. Yeah.
Yes. The state and behavior are distributed among the peers. Peer means the users or individual nodes, or you can say it is also a client or any server that act as a client or server. The peers are independent components and having their own state and control thread. Just like that, they have the own control thread and they are independent. And the connectors are the nothing but your network protocol, and often it is custom, means sometimes or often we are customizing our protocol for the connectors. In a peer-to-peer style, what are the components I am just describing? The state and behavior, their peers, who are the peers, what are the connectors, then the data elements. That this is the network messages, what you are getting as a message from the network. Then the topology, which topology we are using for the peer-to-peer style. It may have any redundant connection between the peers. Just like your mesh topology, redundant connections are there, multiple duplication connections are also there. It can vary arbitrarily and also dynamically. It supports the decentralized computing with the flow of control and resources that is distributed among the peers. Highly robust in the face of failure, means it is something reliable, highly robust if any failure will occur, and also any given node. It is scalable in terms of access to resources. It is scalable to something certain access level to the resource and also with the computing powers. But we should have some caution on the protocol. Then the peer-to-peer lunar lander. We already have talked about this. How they are connected. The blue component, these are the lunar lander 1, lunar lander 3, lunar lander 3, 4, 5. These are some components. They are connected through some connectors, and that connectors are the network protocols. Here it is, we are using the stream connectors. At the lower part you can see we are connecting to the lunar lander 1 to lunar lander 5, LL1 to LL5 with a stream connector. And in between also we can customize some networks and also components like other components. You can check. Okay. Now the Napster. I am the Napster. Means some it is previously it was focusing on some music band. How they are controlling all the connections. When this connection will be connected, when that connection will be given, like that only. The one is at the peer and content dictionary to which the peer A, peer B, peer C are connected. Okay. Then in the case 1, the peer 1 will communicate to the central one, peer B in the communicate to the peer and control dictionary, and when to communicate and when it will give the response. It is given. Okay, this is just a simple architecture in your Napster. Just we will give some assignment how these are originally working. And here in Gnutella, see how the peers are connecting with each other. Peer 1, then peer 2, then peer 3. This is the architecture style we are using in the Gnutella. Okay, the nodes, the individual nodes or individual users, they are connected with a Gnutella style. Then Skype, it is again a peer-to-peer. There are a single login server and some super nodes. These are the super nodes A, super node B, super node C, and to these super nodes the peers will be connected. Just like the super node A, the peer 1, peer 2 are connected here. Then super node B, others are connected. Super node C, others are connected. Through them, they will connect to the login server, and we can access. So this is the Skype architecture. Nutella architecture, Napster, how their architectural style, how they are used in a architecture. Then the insights from Skype, how it is, the working principles of Skype. It is a mixed client server and peer-to-peer architectural address that is discovered properly. Now, initially it was a client server, then peer-to-peer. When you are accessing to the login server, then the relationship is just a client and server. The peer one is accessing to the login server. The login server is the server and peer is a client. Once that peer will be allowed, then it will work as the peer-to-peer. Means I am a peer, I am a node, I will just interact or start my communication with another peer. So first communication is client server, then peer-to-peer architecture address. The replication and distribution of these directories in the form of supernodes and addresses the scalability problem and robustness problem encountered in the Napster. It just uses the scalability and robustness very similar to a Napster architecture model or style. The promotion of ordinary peers to supernodes, that is based on some network and processing capability, and it addresses the another aspect of system performance. Not just any peer, it is relied upon for some important services. Not just like some peer, also it is reliable upon some important services. A proprietary protocol employing the encryption provides the privacy for calls. So we are using another protocol or another proprietary protocol that employs a security measure, and here the security measure is the encryption. It provides the privacy for managing the calls between the peers or nodes, and that are through supernode intermediary. Here the intermediary will be the supernode. Once we are negotiating a call in between the two peers or two nodes, the proprietary protocol will provide the encryption service that provides the privacy of the two peers. Otherwise, other peers may access. If there will not be any privacy to your call, to your voice call or any video call, other may access. So that's why it employs an encryption. The restriction of participants to clients that is issued by the Skype organizer and making those clients highly resistant to inspection or modification that prevents the malicious clients from entering the network. Okay. Here, in the web service, in the program, we have what the client and others are service providers. Here, the service providers are in the some levels. Okay. Now, in the lowermost level, we have the service provider 3, which acts as the provider that provides the virtual message service to the client. Okay. Then here in the web services, we have a service request sending the request with some XML format. Our request is in the XML format. And we are getting the service provider. There are service 1, 2, and number of services are there in the service providers, and it will respond to the service request with some service XML format. Then mobile robotics. It is manned or partially manned, means manually or partially automatic. Mobile robotics. Manned means it is human employment, and partially means partially automatic and partially human employed. uses the space exploration with some hazardous waste disposal. It uses in the underwater exploration. Or these are some major benefits we are getting with our mobile robotics. This is a web service. And what are the issues that is associated with it? Interface with external sensors and the actuators or automatic machines. The real-time response to the stimuli. If you are getting a request, how you will provide the real-time response. Response to obstacles. If any failure or any obstacle will occur, how you are responding to it, how reliably. The sensor input fidelity. How your sensor, how much up to what extent your sensor is trustworthy. Then power failures. If any power failure occur, then how it is managed. And the mechanical limitations means the machinery issues, if they are or not, or any unpredictable events if occurring, how it is smartly managing the events. Here we have the sense, plan and act. Okay, just like we have the data store and the computation and the user. Here also we have the sense, plan and act. It will first sensitize, then it is the computation model part has the work model or any plan how to manage it, then it will act, means it will behave, how it will show its property or show its feature. Then the subsumption architecture. Okay. Here you can see the level 1 and level 0. How the skills are maintained here. Okay. We have the skills with skill A. In the level 0, it is connecting with the skill B with some times, and the skill C is connecting directly through the skill B with some another time. Okay, so there is no involvement through the skill A, and the skill B will pass with some time involvements with the actuator 1 and without any time involvement with the actuator 2. Now a 3-tier architecture, just like in our 3-tier model, front end, back end and the middle one. Front end, back end and the middle part. That is a 3-tier architecture. Here also in robotics we have 3-tier architecture. We have the planning layer, then the sequence layer, then the reactive layer. Okay, and in the reactive layer we have the sensors, they are actuators. Okay, they are interconnected with each other. The reactive layer will receive the data and send the data to the sequence layer, and the sequence layer will receive the data from the reactive layer and send the data to the planning layer. So they are interconnected through it. Now a larger architecture with the wireless sensor network, it is given with here with some service oriented sub architecture, one layer, then the publish subscribe sub architecture, another layer, and the peer-to-peer sub architecture, another layer. Okay. How their interconnections are there with different layers, with your planning layer, with your sequence layer and your reactive layer. It is also given. Now, flight simulators. Another key characteristics with flight simulation. Okay, this applied architecture with flight simulations. Flight simulation means before flying originally or actually, this will allow the flights to go through with your computational model or to go through the simulation technique. That is the flight simulator. What are the key characteristics? Real-time performance of the constraints. It is extremely high fidelity demands since it is highly trusted. It requires the distributed computing. means with different computation from different points. It must execute at high fixed frame rates and often called the harmonic frequencies. It has like 60 Hz, 30 Hz, and up to the maximum higher is 100 Hz. The coordination, it provides the coordination across the simulator components. What are the simulator components? It will provides with all person at the integral molecule of the base rate. If a base rate equal to 60 Hz, then 30 Hz, 50 Hz, etc. are the simulator components here. Okay, so it should be in the multiple of the simulation. How the simulation will run. Then every task must complete on the time because the delay can cause simulator sickness. Means your simulator will be weak and it may not perform in a proper way. Now, it is the continuous evolution. It is very large and the complex millions of the lines of codes. Simulation lines of codes, simulator lines of codes. The exponential growth over lifetime of simulator. Okay. Then in the distributed development, the portions of work are subcontracted to the specialists. Long communication paths that is increased with the integration of the complexity. Once with the increase in their integration means the complexity also will be increased. Then the expensive verification and validation. It is derived by the product of the according to the characteristics given. Then mapping of simulation from software to hardware components. That is just uses the efficiency, that mode is the abstraction needed because of the historical hardware limitations. Okay, some functional models like the simulation model, in we have the vehicle and their environment. It will instructor or the operator area. Then there will be some cockpit displays, visual queuing system, motion queuing system, and audio queuing system. These are some components in your flight simulation product. And there will be a cockpit controls. They will control the vehicle. Okay, again it will be continuous. A continuous evaluation. Here it is. So then, how, if any type of complexity occurs, how you are able to manage it? With some structural modeling, and that model is based on some object-oriented design to model air vehicles, subsystems, as well as the components. For the air model, for the object-oriented design, we have the subsystems and components. The real-time scheduling to control the execution. And what our goal of style? To manage the complexity. It is for the maintainability, integrability, and the scalability. It is the main objective of our style. Then style principles. It is defined for partitioning of functionality among the software elements. It is restricted data and control. The data flow through export areas are only by decoupling the objects. Means with some addition force. Small number of element types. That is results in replicated subsystem. Now, the style principles we are with continuing. The objects are fully encapsulated with their own internal state to manage the complexity. No side effects of computation should be there. The narrow set of system-wide coordination strategies employs the predefined mechanism for data as well as for control passing. It enables the component communication and their synchronization in between the components. One was previously, it was flight simulation, and this is a FSIM or flight simulation, another part. It is a component or architecture we are using, and it is mainly based on some space shuttles, some satellite navigations. We are using the FSIM. Flight 1 is previously flight simulation that was managed for any ordinary flights or commercial flights or any our passenger flights. But the FSIM, it is mainly for the space administration or the space simulation. And here the 5 basic computational elements are the periodic sequencer, the event handler, the synchronizer, and in application we have the components and subsystems are the 5 basic computational elements in the 2 classes. What are the 2 classes? One is your infrastructure class, that is the executive class, another the application class. In the infrastructure class we have 3 computational elements, and in application class we have 2 computational elements. Each of these 5 has the small application program interface, and they have the encapsulated state and severely limited with some external data upon which it relies. Now, with the level 0 architecture, we have the executive level or the infrastructure level, then the subsystem level, and the last one is the component level. In the level 0 architecture, the executive level have the event handler, the periodic sequencer, and the synchronizer are the main 3 computational elements. And in the subsystem level, we have the coordination and coupling in between the controller, export area, and the data gatherer. And in the component level, we have only the component for the computation. Now, here the level 1 architecture. Here the execution with the time synchronization according to the time synchronization. It has the event queue that it will handle the event handler, then periodic synchronizer, just like I told the executive level or any infrastructure level. And another one, we have the subsystem controller A, subsystem controller B, C, D up to N. Okay, and each subsystem control we have the components like component A1, A2, A3 up to AN. Okay, in this architecture it is the level 1 architecture. Now, what are the gist or important components? A great architecture is the ticket to runaway success. If you have a perfect, robust architecture, then you are with the ticket or you have the access for the success. A great architecture reflects the deep understanding of the problem domain. If an architecture is a very robust or good or great, whatever, there is a deep understanding that reflects the deep understanding to provide the proper solution to any problem domain. A great architecture probably combines the aspects of some simpler architectures. It has the tendency or capability to combine the various aspects of simple architectures. It develops a new architectural style with great care and caution. Means it helps for developing a new architectural style. Most likely you don't need a new style, but it helps to develop a new architectural style. Okay. Now,
Okay, let me speak out. Deba,
yes, sir. Yes, sir.
go to the level, go to the slide, go back. Level 1, level 0, then previous one.
Flight simulation.
Yeah. Just you boys see, here they want to develop an architecture for FSIM. What Debabhai told? FSIM is space shuttle. The flight simulator is for the regular flights, but FSIM is for doing simulation. What is that simulation? They just do do some space shuttle will. So they do simulation in the, for example, in our Chandipur near Balasore, Odisha, there are some centers where they send some space flights where they make first the simulation. If the simulation is successful, then only they agree to send the flight, send the shuttle, space shuttle to the space. So they everything simulation to simulate means what? To make some copy of the actual situation. They think that actually they are sending a shuttle, but in computer terminal they make some simulation. So these are the simulator, FSIM simulator. So for that software, they design the architecture. So here they identify what are the different computational elements in that simulator software. They identified something, some computational elements, then what are the sub elements, then they put them in the label 0. Next, Debo, next slide. Debo. Okay, next slide. Here you see label 0. What you do in your DFD. Label 0 is the initial one. What you plan for the future. Just identify the basic blocks. The executive level, the subsystem level, then the component level. They are planning. We will be putting this. This is the level 0 architecture. Then in level 1, they are breaking that further. Next slide, Deba. So think always in your assignment in this type, level 0, level 1, level 2, how you go more detail into the next level, next level, next level. So a good architecture is that architecture which combines more simple architectures. So in the next level, you try to combine very simple architecture. Okay. So thereby you go to the next chapter. So this is an applied architecture. Okay. Thereby go to the next chapter. What is that next?
So designing of the non-functional properties, chapter 19.
Non-functional properties. Non-functional properties is what? We mean that the quality. Functional are the basic functional parameters, and non-functional are always the quality parameter. Architecture, if it has the right quality, then it will sustain, otherwise it will perish, it will be destroyed. So what are the quality parameters? A lot of quality parameters we have read earlier. Always keep it in mind. This is the HP. Most of you, the people have purchased the HP computer, I think. They have their 5 parameters, which they call it as the basic quality. It is almost the same, almost. FURPS, you write down. Forbes model of HP, you check in the net. FURPS. F for functionality. F for functionality. U for usability or user friendly. R for reliability. P for performability. S for security as well as serviceability. Serviceability means if at all any problem comes, whether we are able to do the service and get rid of the problem, or we can able to extend the software. So these are the 5 parameters identified by HP. HP Computers. HP is a very leading company It has a lot of software wing also and hardware wing also. So this URPS is the leading. Other things Debabhaya will be telling right now, almost these whatever Debabhaya will be telling, you can link to this FURPS model of HP. Okay, Deba, you start. What is non-functional property? Okay, before that, had I told the functional property sometimes? Deba, had I told?
Yes, sir. Already told.
So, I think, do you remember any time I had told the functional properties?
So just
Do you
it
remember?
was given a comparison.
Do you remember? Anybody? I had told in the very first class what are the basic functional properties. DC, I had told. Do you remember? Anybody? I had told in the very first class. DC. What is that D? What is C? What is D? What is C? This will be helpful all through your life. These are the basic properties for any business purpose. D stands for demand. Whether you are doing something for which there exists a demand or not. Nirmal, if you want to open a HP laptop store in your locality, you see first whether there is a demand for that HP laptop or not. If you are going to set up a startup software development unit for finance related software, you first see whether I have got the demand in the market for that kind of software or not. So D stands for demand. Then C, what are the constraints to meet the demand? You are a young boy. You do not know how to develop a large software, but you have got an idea to build a startup house. So for that, you have to identify good friends who are very good in software development, who can help you in supporting funds. Then other constraints to identify the location where you will set up your software development house. What are the other constraints? Various constraints, whatever the idea comes to your mind, it doesn't get fulfilled. A lot of constraints are associated. See, only if you fulfill those constraints, then only you can fulfill your idea to meet the demand. Then D stands for deadline. If you want to catch the market, you need to deliver the software by this date, otherwise other competitors will get in. So you have to fix up a deadline. By this date, my software has to come to the market, or my job has to come. My HP store will be opened. My Apple store will be opened at a location somewhere, whatever I plan for. What is the deadline? And another C is always the cost. Cost associated with all these things. DC. So keep always in mind and check in the net. It's there in the book also. So you check it. I'll also check it. So these are the 4 constraints which are the deciding parameter to succeed for any effort. Whatever the effort you give, if at all you don't have the quality, then that effort won't be successful. So those quality parameters are nothing but the non-functional properties. Okay? The non-functional properties are the quality parameters, whatever we'll be studying right now. Okay, Deba, go ahead.
Yes, sir.
Okay,
So we
fine.
proceed with the non-functional properties. So just like sir told the forms, and in here it is very similar. These kinds of the non-functional properties, the 6 kind of the non-functional properties are very similar with the, you can compare it to the, this type of non-functional properties. Okay, here we have the efficiency, complexity, scalability, heterogeneity, adaptability, and dependability are the 6 kind of non-functional properties. And the designing for functional properties. It is any engineering product that is sold that is based on some functional properties, like that will provide some operation or some functions like TV set, DVD player, stereo, or any mobile phone or telephone. What is? It provides the desired functionality in often some in a quite challenging environment with the market demands. Just like DC and DCs are told. The demand, constraint, deadline, and cost. These are very similar. The first one is very challenging, that is the demands. Then competition means you are providing with some deadline and some constant. Then strict deadlines. Then limited budget. That is your cost. So demand with constraint, the deadline, and cost. And that is,
Deba, just
yes,
DC. C for competition. Second C is for competition. Always there will be competitor.
competition. Yes, sir.
Keep it in mind. D is for demand. You meet the demand of the particular item. You check whether that item has got the demand or. Then who are your competitors? Then C is competitors. Who are your competitors? For any Apple phone, for example, Rishabh wants to open one shop of Apple phone in Delhi. So what are the other Apple stores are there nearby? Who are the competitors? You have to check first. You have to sustain yourself among the competitors. So D, C, then D is deadline. By this date, I need to bring out my product. People should get it. People should access it. D, C. First C is competitor. You have to meet the competition of the other competitors of that particular product. And next is C is cost or constraints, varieties of constraints. Okay, Debo.
Yes, sir.
Yeah.
So these are the functional properties associated, and these are challenging one, like DC and DC. However, the system success will ultimately rest on its non-functional properties also. Here means if you have the functional property, then also we should have the non-functional properties for the most success. The system is too slow. Although you are fulfilling the demand, competition, deadline, and cost, if the system is too slow, means it is not efficient or there is some complexities there. If it keeps crashing, what does it mean? If it has many security holes, security breach or loopholes, how will you manage? So it should be reliable and heterogeneity and your efficiency, everything. And every time I change this feature, I have to repeat. Every time for any change of any feature, if I will go for the reboot or restart of my system, then also it will be not a success one. I can't get it work with my home theater. If with my home theater also we are not working, then also we cannot get the success. So with the functional properties also we should have the non-functional properties. Then the functional properties with non-functional properties in Microsoft Word 6.0. It is released in 1990. Both are for the PCs and for the MacBook. Roughly the same functionality. Okay. Now it ran fine on the PC and was successful. It was extremely slow on the Mac. Microsoft solved the problem by charging customers for downgrades. a lot of bad publicity was there. So with the functional properties, we are adding the non-functional properties. One may works with proper functionality with the physics and may fail with the macro. Then another example here. Now we are initializing and we are storing with a library. First, the file system. A file system will be interconnected with a network interface that will communicate to the process scheduler and the memory manager. There is an interlink in between the file system and memory manager. And in the memory manager, that will manage with the process scheduler. Okay. And in the inter-process communication, it will communicate with the memory manager. So initialization and storing it in the library as a documented architecture. What the functional properties and non-functional properties we have. Now here it is implemented. Previous one as documented, then next one is the as implemented, just like the prescriptive and descriptive. Just remember the previous architecture, prescriptive architecture and descriptive architecture. Prescriptive means as documented, descriptive means as implemented architecture. Here the proper architecture is given how they are interconnected. In the previous one, you don't have that interconnection, a proper interconnection in between the components. Here is a proper interconnection in between the initialization, the process scheduler, memory manager, file system, network interface, interprocess communications, and library. Then the challenges of designing for non-functional properties. Only the partially understood in many domains like the Microsoft Windows and the security with the qualitative and the quantitative measures. Then frequently multidimensional issues, non-technical pressures like time to market or functional features are the challenges that may occur while during design of any non-functional properties. Then the guidelines for ensuring the proper NFH. Only guidelines, not laws or any rules. Promise but don't guarantee to give a proper non-functional properties. It is necessary but sufficient for a given non-functional property. It has many caveats and exceptions. Many holes are there and exceptions are also there. Or caveats means many limitations, many constraints. Many trade-offs are also involved for ensuring the non-functional properties. Many trade-offs. You have to go for some deals or then overarching objective. It ascertains the role of software architecture in ensuring the various non-functional properties. At the level of major architectural building blocks, what are the already three things we have discussed: the component, the connector, and their proper configuration. It is embodied and means properly configured in architectural style level design guidelines. Efficiency. The first non-functional properties. It is a quality that reflects a software system's ability to meet its performance requirements while minimizing its usage of the resources in its computing environment. Efficiency is a measure of a system's resource usage. So it also a measure for to manage the economy. What can software architecture say about efficiency? Or it is not efficient for any implementation level. Efficiency starts with the architecture level only. Then only you can say it is a efficient one. Then software component and efficiency. It keeps the component small whenever possible. Keep component interface simple and compact. It allows multiple interfaces to the same functionality. With multiple interfaces also, it provides the same functionality. Separate data components from processing components. It separates the data from also the metadata. Then multiple interface to the same functionality. Just in the previous slide we told. Here, component A, component B, sorry, component A with one type of interface, component A with another interface, I1, interface 1, interface 2, and interface 3. Component for each component A, but their interfaces are different, and which is given in your adapter or wrapper. You can check what are the interfaces, and they are connecting with some another interface. Then software connectors and efficiency. We have to carefully select the connectors. Use broadcast connectors with caution. Make use of some asynchronous interaction whenever possible. It use the location and distribution transparency judiciously. The transparency. Transparency means you should have the proper distribution of the transparency between the architecture. The component, how the components are connected, and their internal transparency with every component. Component A, how it is, how the others are connected with the networks, component B and component C. Architectural configurations and efficiency. It keeps the frequently interacting components close. Carefully select and place connectors in the architecture. It considers the efficiency, impact of selected architectural styles and patterns. Now, the performance penalty that is induced by the distance. Obviously, if the distance in between the components, if it is providing some service and their distance are increased, then it will impose the penalty. You can also, the presentation some given for it, the performance penalty by distance, induced by distance. The supervisor, the global planning, their control, their navigation, their real world. If there will not be a proper distance in between them, we have to give a penalty for it. Okay. So there should be a proper distance. Otherwise, the penalty will be induced by the distance. The supervisor, their global planning, the control, the navigation, the real world modeling, sensor integration, sensor interpretation, robot control, and at the end we have the environment. Okay, so this is the chapter 19.
Okay, this is the chapter 19. This is about the guiding you. Just go back to the previous slide, Deba. Just go back.
Just a minute.
Yeah, just previous one. Yeah, just you see, this gives you a guidance about how decently you can fix quality in your architecture. How thoroughly you can put some quality parameters. The 6 quality parameters what were there in the first slide, all those things, how you can push them in your proposed architecture. Architecture is, what is the definition? Principal design decision. Decision about your design in a very principal way, in a very principle, the most important. Principle means here the most important ones. How you can fix up the design decisions of the most important ones. Most important. Principle means most important here. PDD, that is what is architecture. Principal design decisions. Decisions of the design parameters which are mostly the principal ones, mostly the important ones. So what it says, keep frequently interacting components close. So keep the components which are frequently interacting among yourself in your UML design or library management, wherever You identify the classes, then components, you put them as close as possible. Carefully select and place connectors in the architecture. Place them carefully. Identify which connector is the best connector out of 8. So put that properly. Don't make any mistake. Select that and place that. Consider the efficiency impact of selected architectural style. You have read 6 or 7 architectural style, peer-to-peer, blackboard, different styles you have read. Layered architecture, different styles. So select that very carefully. Which one will be efficient for what purpose? You will see that something Skype was something initially, then they changed over to something else. So people think something initially, then they find problem, they change over. So consider the efficiency, impact. What is the impact of the efficiency of this particular style? Which style you are accepting, whether it is a properly efficient one or not. So accordingly, you fix up the quality of the proposed architecture. If you lose the quality, then your software will crash. Nobody is going to use that. So all your effort, your cost, everything is going to the drain. So it depends, because these are very huge. You check next class, you tell me the silent. So I will ask, what is the size of Nutella software? You tell. And when you are designing, not you, you in a group, 40, 50 people work for 2-3 years to develop such a large software. So when you are designing such a software, you need to be very much careful about the quality parameters. If you can't stick to the quality, then your software is going to crash. Nobody is going to accept it. It will be thrown to the dustbin. Okay, Deba. Okay, take the attendance. I am quitting, and
Yes, sir.
we'll meet tomorrow. Yeah, we'll meet tomorrow for the next. This is chapter 19, na? Yeah.
Sir, to complete
This is
the
chapter 19.
yes, sir. We'll start with chapter 20.
Okay, we'll start chapter 20. Then we'll ask this type of presentation, this Nutella. They are very interesting.
Nutella,
Yahoo,
Skype,
Skype, Yahoo. You will tell, sir, this is the advantage of Skype. This is the problem with Nutella. This is the problem with BitTorrent. You should tell why these quality aspects are not taken care. You should be able to tell. When a software is a successful one, there is a reason for quality aspects in its architecture. If you do not stick to the quality aspect, do it haphazardly, then it's going to crash for sure. Okay, okay. We'll leave. We'll talk tomorrow. Bye, children. Bye, students. Bye. Bye, Debo. Bye.
Yes, sir.
Take the attendance.
Yes, sir. I'm just taking, sir.
Yeah.
Please respond to your roll calls. Just a minute. Okay, Vikas Kumar,
Present, sir.
Jitendra,
Yes, sir, present.
Asim Guleria, Asim, absent. Ashutosh Gupta,
Present, sir.
Pratik Jaiswal,
Present, sir.
Subham Kulkarni,
Present, sir.
Rekaj, Mohammad Rekaj,
Present, sir. Vikas present.
Nirmal Panda,
Present, sir.
Siddharth Rautray,
Present, sir.
Andrila Saha, Andrila present. Andrila Saha present, absent. Absent. Then Ranveer Singh.
Yes, sir. Present. Present, sir.
Then Somosekar.
Present, sir.
Rishabh Soni.
Present, sir.
Akshay. Akshay absent. Rahul Sahu.
Yes, sir. Present, sir.
Chandrakant. Chandrakant. Chandrakant absent. Shibam Dalmia. Shibam Dalmia. Shibam Dalmia absent. Okay, Shibam Dalmia. Then Guduri Achyut. Achyut. Rakesh Kumar.
Yes, sir.
Mahendra Sharma.
Present, sir.
Srilekha. Srilekha is absent or present? Srilekha absent. Okay, bye. You can be offline.